In this video, I'm going to show you division with decimal dividends. So let's say that we're trying to have $20 and we're trying to share that with, share it equally with, let's do 8 people. So this problem would look like this. It would be 20 divided by 8. This is our dividend, and this is our divisor right here. Now, if I were to set that up using long division, I would want to write this out as a decimal problem with a decimal dividend, and I'm going to share that $20 with 8 people. Now, with decimal dividends, there's literally only one extra step that you have to do, and that's to take your decimal and move it straight up. And the reason that that works is because when we're doing long division, we're already using place value. This right here, this is the tens place. The digit that will be in our quotient right above it is also in the tens place. Same thing with the ones place, the tenths place, the hundredths place. The decimal point right here is just a divider between our whole numbers and our decimal numbers. So I'm ready to go ahead and do my division. 8 does not go into 2, but it goes into 20 twice. 2 times 8 is 16. A remainder of 4, but I'm going to regroup that with this 0. 8 goes into 40 5 times. 5 times 8 is 40. And I've got one more 0 to bring down, which 8 does not go into it, so I can put a 0 right above that. So my answer is $2.50 per person. And you'll notice that I did not keep bringing the decimal down as I did the problem. The decimal point is only to help me separate my whole number from my decimal numbers in my quotient. So the only place that I need to do is move it straight up to the correct place in the quotient. Let's look at another example. Let's say I have 32 and 95 hundredths divided by 6. I'm going to bring my decimal straight up so that it will separate the whole numbers and the decimal place values in my quotient. And now I'm ready to divide. 6 doesn't go into 3, but it goes into 32 5 times. Regroup here. 6 goes into 29 4 times. And 6 goes into 55 9 times. Now you'll notice I have a remainder right here. And there's a couple of things that I can do with this. I can just stop my problem right here if all I care about is going to the hundredths place in my quotient. That kind of depends on the context of the problem, how accurate I need my answer to be. Or if I want to, I can always place a 0 right here in the thousandths place of my dividend because there is nothing in the thousandths place, and then I can continue my division. So 6 goes into 10 one time. And I can keep putting zeros in place values here as long as I want to. Sometimes when you do this, you will just keep going forever and ever. Sometimes 6 times 6 is 36. Sometimes you'll get to a point like on this one right here, where if I put another 0 here, I can see I'm going to be doing the same thing over and over again. It's just going to be a 6 repeating over and over again. And that's where we have a little symbol that looks like just a little line above the 6. We call that a bar above the 6. And when I put that bar up there, it means that that 6 will repeat forever. It will never stop. It will keep going. Because if I continue with my next place value, there would be another 6. This would be 36. This would be 4. I can continue placing zeros and bringing them down, but it's going to be 6s that are going to repeat over and over again. Sometimes decimals will terminate or end. Sometimes they will end up repeating, and sometimes they will never repeat and never terminate, and they will just be random digits continuing forever and ever. Let's look at another example. Let's do 53 and 207 thousandths, and let's divide that by 9. Don't forget to bring the decimal straight up to separate the whole numbers and the decimals. And now I'm ready to go ahead and do my division. 9 doesn't go into 5, but it goes into 53 5 times. 9 goes into 82 9 times. 9 goes into 10 once, and into 17 once as well. Now I have a remainder of 8. I can continue with this problem, or I can stop right here and assume that 5 and 911 thousandths is accurate enough for whatever my purpose is of doing this problem. If I want to continue, I'll need to place another 0 here, bring it down, and keep going.